Inverse functions. You thought I was gonna mess it up. You thought I was gonna mess it up.
I was just saying the way.
No!
Mr. Orchid doesn't mess up.
I do actually.
Why are you always lying?
No, again, if I don't write functions with fun capitalized, remember?
What's the deal?
Well, I'd have to think of something because I've never had that issue.
Really?
No. I catch myself about once or twice a week, but nobody's ever busted.
Well, wait, why is it all capitalized on there?
So, inverse functions, I didn't write this. I plead the fifth. Inverse functions are made out to be a lot harder than they really are most of the time. Okay, I'm not going to tell you it's easy. Okay, there's some algebra involved, but conceptually, I think that math teachers tend to turn the screws on this and make it harder than it needs to be. Okay, so an inverse function literally is you switch the x and the y. That's all you're doing. Okay, I'm going to show you how to do that algebraically and graphically. Okay, but that's all you really have to remember. If you can remember, oh, I need to switch the x and the y, you could probably see what else needs to happen.
So your x is your y and your y is your x? Like on the axis?
Yes. So, and I'll show. So let's look at this algebraically. Let's consider this function. We could graph that now, right?
No.
Yeah. What translation is this? Left.
Down
Down
five.
five.
I was trying to draw like with a bunch of different functions instead of just a line.
Yes. We are headed into nonlinear functions pretty heavily.
Why can't we just do linear ones when linear stuff and then non-linear ones stuff where you go?
I think you'll be okay, but let me know if you're not. I can show you a linear function. Okay, so calculate the inverse. If you want to write it like this, you can. It makes it easier for some people to see it. Right? What do I do?
Switch the x and y.
Wow. You guys are geniuses.
Well, Dad, I pictured all this with it. I took my smartphone today. Oh no. I only ate 10 copies.
That's funny. Okay, now, is this in a format that we usually see equations? So what do we need to do?
I don't know.
We have to
Solve for y.
distribute that square root.
Because we like y equals, right?
We just
So we need to solve for y. This is where the algebra comes in. Algebra. We're moving everything to the left to get y alone. Square root. Yep. Be careful. Okay. When you square root a squared, they do cancel each other, but you have to worry about both of these cases. Think about if there's a negative in here, you square it, it makes it a positive, you can square root it. If there's a positive in here, right, both of those have to be considered. Right? So if you square root a square, put the positive, negative out here, and then we can minus 3, right?
Oh, it doesn't go like the -3 goes out?
It's outside the root. You can put it on the right. I don't
Okay.
care. But I put it on left just because it's cleaner.
Okay.
you could definitely put it out here. You know addition's commutative.
So you wouldn't just do the -3 and the 5?
No, because this is closed, this is in prison, right? It can't get out. So don't put anything in there. So this is our answer, we have to write it properly.
So that's the answer?
We have to do the F of.
You need to write it as inverse. No, yeah,
That's your answer though?
yes.
Yeah.
You just calculated the inverse,
And that's the answer for both of them now?
When it's inverse, you have to put that little -1.
yes. That's what that means.
So that'll just be your answer, just that.
Yeah, if I asked you, if I gave you this function, said calculate the inverse of f. Done.
Where'd the 5 go?
Yeah, where'd the 5 go?
Oh,
Yeah,
It's supposed to be a 5 and a 5.
Okay.
I wrote it from memory and that didn't work very well this time. There, now we're good. Yes.
So this is just repeating referencing calculus, will we actually do all of that? Or no?
I give you a way around that,
Oh, yeah?
actually.
Cool.
For derivatives. It's a formula. So there are two ways to do derivatives of inverses. One is to calculate it, then do the derivative. The other way is just a formula. And that's where the AP exam actually usually change.
When you graph it, you're going to just graph the inverse of the sum.
That's one way to do it. Yes.
Would you need to graph it? Will it be like solving graph?
So sometimes yes, and I'm going to show you that. So let's just graph this one. You're so anxious. I'm very
I feel like I want to make sure
So is that the answer for both of them?
This is the answer for the inverse of f. This is the algebraic method.
Okay, so you wrote
Yes, actually, that's the whole answer.
Or y equals, and then the equation, then you put x equals the equation. So that answer works for both.
You're talking about why did I write it this way?
He's thinking f of x and f of -1x
F of x
are this like two
and
different
inverse.
You see right above where you wrote the y, right above the x, x equals, down one feet that right there. So does that answer work for both? Like that one and then the one right under it?
This.
Yeah, and the down one? Right there?
No, you have to solve this for one. So this is the inverse, yes.
Yeah.
The proper math
So
notation
when you
is to
solve that, you
carry it
get
out to this
When
step.
you solve that bottom, then you get the inverse.
Yes.
So what is the relevancy of the bottom?
This, I just named it y equals. See how it's the same? Yeah, so you see that you're switching the x
Oh,
and the
so
y.
you did a conversion.
If you want to skip this, you can. You can just go from here to here.
So why not
You're
just
switching.
Why not just leave it in that first way since you already have the y alone?
Most people find this easiest. You can leave it at the x if you want. If you want to work it all the way through and get it. That's fine. This is easier for most people to see. So down 5, left 3, right? Correct?
Okay, we're graphing. Sounds like
This is
four.
f of x. Left 3, down 5? Quadratic. Parent function, I just sketched it.
Wouldn't you get 2 points for every one x value you put in though? Right? Oh. I was trying to get my point across. But like if you plug in for x, wouldn't you get 2 y?
Here?
No. That in the equation.
Yes.
So you have 2 lines.
So here's what he's referring to. This is a function that does this. He's ahead of us. So if I plug an x in, I we'll get 3 plus something and 3 minus something. I'll get 2 y values. So is it a function? No, this is not a function. Okay. So that's one way to graph this, is to know that your square root function, move it left 5, down 3, correct?
So wait, that wouldn't be one of the
Another
functions that's like a curved weird line?
Oh, no, I used to split your graph, so I thought you just split it.
There's your inverse. Now that's graphing using your families of functions knowledge.
Which, that's the inverse graph?
Graphing the inverse.
I thought since it had a square root, it had to be like not and just like a little.
Yeah, but it's positive.
Positive square root, negative square root. Moving those this direction.
Definitely because it's a positive or negative. If you didn't have that, you would just do it.
It's the one, and then that one, that's the. Are we gonna have a test on this?
Good question.
Yes. This function is the red.
That's what I'm saying.
See, I thought the first two tests we took were hard, but I understood the practice. I don't even understand the practice.
So that's one way to graph these. The other way, okay, what point is this here? -3, -5? What point is that? You switch them, right? So every point that you graph, you switch the x and the y, you can generate your new graph by flipping the points.
I'm kind of confused now, actually.
Yeah, me too.
So, I thought it was a rational function, right? So wouldn't it
It's a
be
radical function.
okay, radical? Would it be? I thought it was just one, like,
The positive,
okay.
there's also the negative case.
Okay.
Right, so we have 2 radical functions, 2 square root functions here.
Okay.
In this case. Sure. So if you can get a few points here, if you switch the x's and the y's, you can graph it that way too. Okay, so graphically it works. If you're a very visual person, if you're not, ignore this. We are reflecting across the line like this. That's another way to think about it.
So how would
That
you-
is graphically switching y and x. That's all you're doing. Okay, Justin.
So like, if you just wanted to graph the inverse of that function, could you graph it and then just flip x and y?
That's it. Yeah.
So we don't have to do the whole
You
equation?
would not have to do this. If you're just asked to graph it, you can just graph the original, switch the x and y, is good to go. Yes. Okay, JD.
And how would you switch it to go to that?
You mean the red one?
Yeah.
That would be if this is a negative.
Okay.
If this is a negative, the quadratic's down.
Yeah.
When you do the inverse, it's going to automatically give you this direction. It's going to work for you. Right.
So the inverse will be like in this example, is it only facing the right because it has the square root? The plus or minus the square root is the reason it's facing the root?
Well, it's because this is a positive opening of parabola. This has to be a positive x value opening the square root function.
So, like, can you tell like by can you tell just by looking at the inverse equation which direction it will open? Or would you have?
It would open to the left. The x had a negative on it.
Okay.
Remember families of functions?
Yeah.
If there's a negative on the x inside the parentheses, it reflects it across the y-axis.
So inverse
Okay,
always.
since the negative is out here, that's where we get this. Okay.
Is the inverse always gonna have positive and negative in each?
No, just with some quadratics. Anything with an even power. So like a linear function would not have that.
So it's a negative power, it's not a power.
No, negatives are okay with negative roots.
Okay, so if it does, what if it doesn't? Then it's just gonna be one little strange thing between the apple and toast.
If,
If it just has negative, it just has positive, and it's only gonna be half of the randomness.
basically, yeah. The only time you have to deal with that is with the quadratics.
When are we taking this test period?
I just need to know what it is.
Just not before Friday, right?
No, no.
Sweet.
Ooh, I was gonna say, I want to know.
Do you want me to show you another one?
Yeah.
Linear? You want an easier one or?
Whenever we're gonna see.
Well, we should probably do a linear since we did one non-linear, considering that the linear process is
So it's the same process.
because if I wouldn't have just asked, I would have never known that I didn't know that negative.
Let's see if the book has a good one. Okay, I'm gonna write this up here. If you wanna work it, do it, go ahead, because I'm gonna be real slow. So again, inverse concept, switch x and y, right? And then solve for y. This is our inverse, so we need to rewrite it. Check your work if you do it yourself. Linears are much easier.
Yeah.
They should go very quickly. But again,
Okay,
it's
so
the
you
same
have
process.
F right there, F, and then what are those two little symbols?
-1, superscript, x.
Why did you do it?
That's how you say it's F inverse, that's the notation.
You want me fine? It's over 2.
Yeah, that's fine. I will put this in blue. You will at times have to graph it.
I'm sorry, I have a question. How come it's -1?
-1.
Because that shows what it
F, yeah, that's how we note it. You don't write F, then the word inverse, you write F to the -1. That's F inverse of x. Where's your inverse function?
That's still just the inverse reflected on the light.
Yeah, so if you drew that line, see how it looks? So they will always cross at that line, right? Because that's where the x and y matches. In this case, it's 4, 4. x-intercept and the y-intercept will always match. So this is 2, 0, 0, 2.
Do we put the point where they meet as the thing? Or is it just graph the
If it says and graph,
Otherwise, we just put the.
if it just says this, when you just do the algebra,
So we just use an head circle.
you're good. You don't have to graph it all the time. But so what, x and y switch, linear, a little easier to see.
Is the same for like, so,
Everything I can show you is all the same process and concept. It's just different shapes.
you said the X and Y are the same, is that true? The max X and Y? So like, when they first, so when the red line hits the Y axis, it's the same as when you do it with the X axis.
Do we take
So when the same, you turn the X, it's the Y axis, and it's the same as
Here and here.
yeah.
0, -4, -4, 0. Yeah. It works. And I even drew it accurately. How about that? Chan.
I have 3 questions.
Oh boy.
First, how would you cut with an absolute value equation? Second, how would you do that with a two-row equation?
Okay. For the sake of time, absolute values, example 1 and 2.
Time is money.
There's a cube root function in example 3. Okay. I want to get you working because I want to get time. So those of you that understand, here's your work.
What if you don't understand? Can you still
Then we need to talk.
It's
Oh, yeah.
Is that what it is?
I think so.
I think it's called a catch 22. Well, this is like a catch 33. I'm named 3.
Yeah, it's a lot of writing, but and picky and choosy.
Is that first one 19 or
15.
which time?
Yeah, 1G. This is the one gangster problem. 15. 21 to 23, and then so on and so on. If you get stuck, 5 minutes, cut it off, come tomorrow with questions, okay?
How long do you want us to be spending on like this graded listening table?
They're gonna take a little longer. I would limit myself to, like, the linear programming one's obviously 10. If you're stuck, 10 minutes, cut it off. If it takes you 15 to do all the work and you understand it, that's okay. But again, just be wise about your time, because I know a lot of you juniors are in 4 AP classes, 5 AP classes. Just be wise about your time. Okay, so here's a chance to start. If you get stuck, you can ask questions.
Will you miss you?